doing consolidation. Consolidation of what? We are consolidating our algebraic expressions. Consolidating, I think I've said this before, but it means we're just bringing it all together. And so in this bringing it all together, the first thing we really learned about was we learned about this terminology. And so let's do a quick recap of this. You guys can put the answers to these questions in the chat if you know them. First question is, how many terms are in the expression? So remember, this whole thing would be considered my expression. How many terms would you guys say there are in this expression? Yahu is saying 3. Bree is saying 4. There's not many of us in here today, so I hope that you're all gonna participate anyways. So actually, what it is, Liaho, is 4. And the way you can also do it is, remember, our terms are separated by pluses and minuses. So I've basically circled all of my pluses and minuses that separate numbers and variables. And look at what we end up with. We end up with 4 terms. And so how many terms are there? 4. What is the coefficient of r squared? Can you guys tell me that? This one is a little bit of a tricky one. It's not 1. And let me tell you guys why it's not 1. When something is in a fraction, okay, if I have, and let's go, if I have p over 2, what that actually means is, it means I actually have 1p over 2. I don't know why I'm writing skewed today. Let me try to fix this up. Okay, that should be better. So it actually means, and let me try this again. So if I have a fraction where I have something like p over 2, I'm still writing skewed. I don't know, guys. Sorry. If I have something like p over 2, what it actually means is it's 1p over 2, which actually means what? It means that what actually happened is that I had a half multiplied by p. And think about it, it would have been a half times p over 1. And if you just multiply across, you get 1p over 2. And so actually what's happened here is this p over 2 actually means half times p. Because remember, this is basically saying p divided by 2, which really means half of p. Okay? And so if we have half of p over here, what my coefficient would be, remember, it's what is being multiplied to my variable. And Bree, you're close. It's not 2, but what's actually being multiplied to my variable in this case is a half. So I know that might be a little bit confusing for you guys, but the coefficient is actually a half, simply because we can't just ignore the denominator. You could look at it like this. You could look at it like you're saying r squared. We have r squared basically over 2. If we look at this little bit, okay? If we look at that, it is r squared over 2. And really what's happening here is we have 1 on the top here. And so this coefficient is 1 over 2. You could look at it like that. And because we know, we can see we have a negative in the middle over here, my coefficient is actually a negative a half. So I want you guys to just let me know, please. Did you follow my explanation on how I got to negative a half for the coefficient of r squared? You can just put a yes or a no or a thumbs up or a thumbs down in the chat. Okay, I see a thumbs up in the reactions. I don't know who it was, but I did see it. Liaho, Kaylee, Amo. Okay. Okay, I'll take it. Bree, you're asking where does the negative come from? So like I said, because we're looking at r squared over here, so this is the term that r squared is in. If you look at the sign in front of r, it's a negative. And so really what's actually happening is we have negative r squared over 2, if I were to break it up. I don't know why I'm writing skew. What is happening? Oh, what? Yeah, so that's where the negative comes from. I just took the sign that was in front of R. Okay. Alia, you understand. Happy to hear that. The next question, we're looking at C. What is the constant term of this expression? Itandile has answered it very well for us already. It is +3, and I'm glad you included the sign over there. Remember, what is a constant? A constant is a term with no, look at my handwriting because I'm trying to write straight. I don't know what happened. Maybe I'm not sitting in the right place. Wait. Mm, we have, oh, that's better. Term with no variable. Okay. So remember, a constant is a term that does not have a variable. And then this last question is, determine the value of p minus r squared over 2 if r is equals to 3 and p is equals to 1. So remember, guys, when they give us actual values now for our variables, what we have to do is we have to do substitution. And so you're going to actually substitute these numbers in for the variable that they've told you. So what will that look like? They only want to know the value of p minus r squared over 2. Now, if we look at how this would work, they've told us what is the value of this if p is 1. So if p is 1, then this is actually going to be 1 on the top here instead of p. And then we're going to go minus, and instead of r squared, we know r is actually -3. So we're going to go minus r. Nope, we know r is -3. So we're going to put in our r and we're going to square it. And then we have over 2. Now, can you guys tell me what is -3 squared? It is 9. Why is it 9? Remember, when we multiply our signs, it's a negative multiplied by a negative. And remember, when we have the same signs, my answer is going to be positive. So here, this is going to be a +9. And we could have still had it in brackets. But remember, when we have it in the brackets, we would have removed our brackets by multiplying my negative into the brackets, and it would have just left me with -9 in any event. So we'll leave it as 1 minus 9 over 2. Now, can you guys tell me 1 minus 9 gives us what? Sorry, if you see me looking very strange. Oh, I'm so scared. I have a window right in front of me, and something just flew at it. Like a bird, I think, but it sounded very large. It's so scary. Anyways, it is -8. How did I get that? Let's draw a line. And I think let me extend it a little bit. Okay. You can see where I extended it because it goes cute, but whatever. Let's call this 0. This is going to be 1, 2. I know when I go backwards, we go -1, -2, -3, -4, -5, -6, -7, -8, and -9. Okay. What we're doing here, we started at 1 and we had to -9. When we minus, we move to the left. So 1, 2, 3, 4, 5, 6, 7, 8. No, no. We didn't start at -1. We started at +1. We started at +1. When we minus, we go to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there we end up at -8. So my answer here is -8/2. And someone give me my final answer. -8/2, what can we simplify that to? -4. Good job. -8 divided by 2. We can apply SNV here. It's our signs. Negative divided by a positive will give me a negative. Numbers. 8 divided by 2 will give me 4. Okay. So that is that. On that, I hope we're all following up today. It's not been too hectic so far. Moving on, we'll try something a little bit nicer, a little bit more tricky. Ooh, good luck, Christian. Um, good luck to you. Itandile, yes.
Mom, I'm asking, why does it have commas after the
Why
brackets? Why does it?
Oh, so it's saying the instruction to us is add the following expressions. So basically, this is expression 1, this is expression 2, and this is expression 3. And what they want us to do is they want us to add them all together. So the commas in between are to separate them because it's right now it's a list of expressions. Make sense, Itandile?
Yes, ma'am.
Cool. And so now that we've now actually read this instruction, what we're going to do is we want to add. So I'm going to go, well, it's going to be 5x squared minus 3x cubed plus 2x plus x minus x squared. There you go. Plus 2x cubed
minus 5 minus 4x cubed
squared.
squared.
There you go. Now, I kept these brackets in on the second and third expression. Why? Because remember, when we have brackets, we have to take our sign and the number in front of my brackets and multiply it in. Do you remember that, Itandile?
Yes, ma'am, we have the distribution.
Yes. And so let's do that now super quickly. What is that going to look like? So my 5x squared minus 3x cubed plus 2x is just going to get brought down. And now let's remove my brackets here from this first expression. Itandile, you still with me?
Yes, ma'am. I'm gonna say plus 1 bracketed x.
So we don't have to put it in brackets. And I'm also not going to put in the 1x because I know 1x is just x, but you're correct. Yes.
Minus x cubed. You squared, sorry. Squared. Plus 1 times 3 is 1 times 2 is 3. Which is gonna be 3. 2 is it's 2.
2
x cubed minus 1 -5 plus, which is gonna be -5 minus, which is gonna be -4 because it's negative times a positive. It's x cubed squared. Squared.
Okay, so that was nicely done. What's our next step now, Itandile, now that we've removed our brackets?
Ma'am, we have to put them in like terms.
Yes. Why am I not gonna start like changing my exponents and stuff? Why can't I use exponent rules here and say
Ma'am,
2x plus x gives me 2x squared?
ma'am, because we're not doing our exponents rules, we are doing like terms.
100%. We're not doing, I think this was just x. We're not doing exponent rules because remember, exponent rules only apply when we have multiplication and division.
And division.
When we're doing like term rules, my like term rules will apply when I have addition or subtraction. And if you look at that expression, Itandile, can you see that we only have addition and subtraction?
Yes, ma'am.
That is great. So now tell me which ones are like terms.
Ma'am, we're gonna say positive 5x to the exponent of 2 plus, no, negative minus x to the exponent of 2, negative 4x cubed squared. And the other like term, the next like term we have is negative 3x cubed with then positive 2x cubed, and that's it. And then we have negative 2x, and we have negative, and then we have positive x, and then we leave 5 as a non-like term because it doesn't have a match.
Good job. Next. So now add up these like terms for me.
Yes, ma'am. So, ma'am, I'm gonna start with negative x cubed minus positive. No, it's plus because so it's gonna be negative 1. No, it's gonna be positive 1 x cubed and then minus x, which is gonna be x cubed.
Okay, so you're starting with your cubes. Okay,
It-
so you said negative 3 plus 2 is what?
Negative 3 plus 2, ma'am, is negative 1 x cubed.
Negative 1 x cubed. Okay, great. Then you're dealing with your x squares.
My x squared, ma'am, is negative 1 x squared.
How did you get negative 1? Tell me.
Ma'am, I said 5 minus 4, which is negative 1. No, it's positive 1. X cubed minus x cubed, which is negative 1 x cubed. Because
No.
I have
So look what it is. We have 5. We first have 5x squared. Then
yes, ma'am.
we minus 1. We minus this 1x squared
4,
here. Do you
ma'am.
see?
Yes, ma'am.
And that leaves me with 4x squared. Then
Yes,
I
ma'am.
minus 4. That leaves me with 0x squared. Do you see that?
Yes, ma'am.
So
Oh,
actually, we don't write anything in because it would be plus 0, but it doesn't make sense to now say plus 0. So we're just going to leave it out.
yes, ma'am.
Okay?
Yes, ma'am.
Try doing these ones now, just the normal x's.
It will be, ma'am, positive. It will be positive 3x.
It would be positive 3x. You are so right. And last,
Negative 5, as it doesn't have a like term.
negative 5. And that is my final answer. You happy with this, Itandile?
Yes, ma'am.
Good. So what I want to tell you is be careful with your adding and subtracting of your integers. You have to be super, super careful. If ever you're unsure, even if you think you're sure, do the number line. Just use your ruler. I used to use my ruler as my number line, and I used to just count on my ruler because it's so easy to make silly, silly mistakes and then you lose marks like that, right?
Yes.
Okay. Rorisa, you just arrived half an hour late. Isanita, thank you so much for answering that question with me. We are gonna move on to a similar but different question. what is this? A. So I should be able to do that without messing up that. So from 2a plus 3b minus 4c, subtract negative 2a plus 3c minus. So it says I have 2a plus 3b minus 4c. From this, I need to subtract negative 2a plus 3c minus d. I don't know why I started randomly writing out of my line. Plus 3c. Okay, so that is that. What I want you guys to pay super close attention to is that if this said subtract negative 2a plus 3c minus d from this next expression, it would still be the same. Remember, if they tell you subtract something, subtract whatever from whatever, you're going to start with what you have, and then you're going to do your subtraction. So it's going to be block minus circle. And that's what we've done here. So when you get these questions like this, always think, okay, subtract. What are they saying? I must subtract, and I'm subtracting from what? So they could change the format of this and say, from this, subtract that. And so always be careful what they're saying, because that will change which one you have first. So pay attention to that, and I hope that that makes sense to you guys. Anyways, what we have here now is we have this expression. First things first, nothing I can do here. I'm bringing it down. The next thing I have to do is get rid of my brackets. So I'm going to distribute. When I distribute, it's negative 1 times negative 2a, which is going to give me a negative times a negative gives me a positive. 1 times 2 is 2, and a is left. Then we have negative 1 multiplied by a positive 3c. It's a negative and a positive, which is going to give me a negative. 1 times 3 is 3. C is just left there. Then we again have negative 1 times negative d. A negative times a negative gives me a positive, and d is just left over there. Okay. Uma, you are also joining Rory-san half an hour late. Hi, better late than never, I think. Okay, so that's that. So now that I've gotten rid of my brackets, what is my next step? Let's look at some like terms. That's all I'm seeing that have A's. And remember, like terms, same variable, same exponent. C. And then, yeah, B is on its own, it seems, over here. And D is also on its own. So if we were to now go and add up these like terms, it would look something like this. I'd go 2 plus 2 is 4, and 4 what? 4a, plus 3b, minus 4c, minus 3c. Remember, we're starting at negative 4. If you go backwards 3 times from negative 4, it would be negative 4, negative 5, negative 6, negative 7. So that is negative 7c plus d. And this is my final answer. I know it may feel long and it may seem like this is not it, but look, once we don't have like terms, I can't do anything. And so this is my final answer. I'm not gonna go through the chat. Umar, that's okay, but you're late. Yes. Yeah, you got the answer correct. And last one, before we go into our brain break, is going to be A over here. Now, when we're doing A, I want us to first look at, remember, we have to simplify first either our numerator or our denominator. Can you guys tell me, in our numerator or our denominator, are there like terms for me to simplify? Handoy is no. Christian says yes. And we have a tiebreaker. Bree is our tiebreaker, and she has said no, but now we're tied again. Italia says yes. Um, so what I want you guys to see is there's no like terms here. This is a squared, and this is a cubed, and this is a constant. So in my numerator, there are no like terms. And in my denominator, there's only one term. So there can't be like terms there. So I can't actually simplify this fraction any more than it is. What I can do, though, to simplify the expression is I can break up my fraction into its parts and go minus 6a cubed over 2 plus 4 over 2. So what I've done now is I've broken up my fraction into its parts. And so now, remember when we do our order of work, we first identify the terms. I've broken up my fraction now into 3 terms. I simplify each term first, and then I add or subtract like terms. So if I were to simplify my first term over here to a squared, well, really what's happening here is it's 2 divided by 2, which just leaves me with a squared. Why? Because 2 divided by 2 is 1, and so it's 1a squared, which is just a squared. Then we have over here 6a cubed divided by 2. I can go, so there's 2 ways you could do it. You could go SNV, but I did that method in the last video. So in this method, I'll show you guys 2 goes into itself 1 time, 2 goes into 6 3 times. And so what we have left is 3a cubed over 1, but I know we can just write that as 3a cubed. I don't have to do the denominator of 1. Why was it a negative? We had a negative in the middle over there. Okay, and last but not least, 4 divided by 2 is going to then give me plus 2. How did I do that? 2 goes into itself once, goes into 4 twice. Okay, and this is my answer. Do I have like terms left here? No, I don't. Because we have a squared, we have a cubed, and then we have just a constant. So no like terms. This is it. We are done. Uma, I hope I'm not still frozen. Um, but yeah, that is that. Um, can you guys give me happy face or sad face to let me know how we're doing? Yes, Rory-san. If you're about to ask me to repeat what you missed, I have to tell you I'm so sorry. I can't repeat half an hour.
No, ma'am, I pressed there by mistake.
Okay, no problem. I saw Christian. Christian, you're a little bit upset. I know it seems different. It's just that the way the questions are asked is different. But Christian, what actually happens is maths is the same. Maths is the same all across the board. And so if you can just understand the concepts and understand almost like the principle behind the maths, you will be able to apply it to your Cambridge questions because maths is the same. So Christian, if you can tell me that if you understand the concepts I was explaining here, um, I'll be happy with that. Because if you can understand the concepts here and take it into your Cambridge work, you should be set for your exam. Okay, you're saying thank you, so I'm assuming you understand the concepts then. Don't panic. Don't stress yourself out. You know your work. If you know these maths concepts, any question you will see, you'll be able to apply it. So for now, I'm going to skip these two. We're going into our brain break. Oh, and I remember making this. I also do my lesson preps very far in advance, guys. So sometimes I don't remember what I did. And we're gonna do the same as last time. I'm taking max 2 hands per square. Alia doesn't like one must go. Uh, sorry. Nkuli, yes.
Hi, ma'am.
Hi.
Okay, ma'am. I think a lamp must go.
You think so? Why?
I've never tasted it, and seafood is just too good to get rid of. Chicken is the South African mother food, and beef, we just can't get beef out of our lives.
Nkuli, I'm so sure you must have tasted lamb. You know, like those lamb chops on a braai.
No,
Like
I have not.
100% you have to have tasted lamb. But okay, I get that. We'll go with lamb. I saw a lot of people saying that in the chat as well. Yeah, that's that. Thanks, Nkuli. Let's see what Liacho has to say. Christian, I see your hand up, but you can answer the next one. So keep it up, but you're not gonna answer this one. Oh no, sorry, Liacho, I muted you. Just undo that.
So, ma'am, I don't know which one to pick, ma'am, because, like, yo, I like everything here, but, yo, if I had to pick, yo, I don't know what to pick, yo, this is such a tough decision. You know what? I'm just gonna say lamb.
Oh my
I'm sorry,
God.
ma'am. Sorry, ma'am.
Yeah, it's okay, Liacho. I might say beef, personally, but
Okay.
all of them must go. Yeah.
Okay, thank you, ma'am.
Thanks, Liacho. Isandile and Christian, I'm taking your hands for the next one. So that's that. All of them must go. Roisan, you'll do the one after this now. I see your hand. Okay, next one. These are like, OG South African Christmas Christmas food. So yes, Christian.
Hi, ma'am.
Hi. What do you think must go?
So, ma'am, I think the peppermint tart and the trifle, for me, I'm more a fan of things that are really, really sweet. I prefer something
Oh,
that's meat.
okay. I get that. Yeah, I could see then how you wouldn't like the peppermint tart because peppermint tart is very sweet.
Maybe not. We may not be sure.
So which one did you say must go,
I feel
Christian?
like it's the peppermint tart for me. And the malva
Okay.
pudding. Because the pudding has a lot of sugar. Hey,
Yo, I love malva pudding. I like the sweet stuff. But thanks for answering, Christian.
no problem, ma'am.
And then Itandile, I think you were next. Yes, Itandile.
Mama, I have to debate with y'all. Ma'am, I
Uh-huh.
had to debate. No way. Ma'am, Christmas is all about everything. The jelly and custard must go. No way. The jelly and the custard. No way. No
I
way.
would also get rid of.
The
I'm
jelly
stuck
and the
between the jelly and custard and trifle. I don't really like trifle so much. It depends, on
ma'am,
who
you
makes
know
it
what
and what
is
they
wrong
put
with
in.
the trifle? You know what is wrong with the trifle? It's like,
Mhm.
ma'am, it's too soggy for me. For
I was
some
just
reason, it
gonna
was
say,
soggy. It
yeah,
was soggy. So, as much as the one thing that should go is the jelly and the custard. Yo,
okay.
man,
Yeah, I think I'm gonna agree with you there. I think, but I
all
don't know,
that
you see, I
waiting.
really like jelly and custard also.
Like for the people who love jelly and custard, I clap hands for y'all. Jen, I clap hands for y'all. Like,
You
no
don't like
way.
it, Itandile?
I don't like it, ma'am. I think it's because like I never liked the jelly and the custard being in the same bowl. And then you know what I used to do? I used to like make them separate. I used to go ask for another bowl and I used to like
Oh
scrape
my
off the
word.
custard
So
and
much
stuff.
work you could do there just for it to go together in your mouth again. Come on.
No, ma'am. No. The haters should
Anyway,
hate, but then the jelly and custard should leave South Africa.
I mean, okay, Itandile, we'll take your word for it that it's disgusting, but I like it. Okay, that was that. That's on this one. Thank you, Itandile, for answering that one. And then I see Rory-san and Liaho's hand is up. But Liaho, you answered one already. I saw before Kaylee's hand was up. So Kaylee, if you still want to answer, I will take you over Liaho. Sorry. Liaho. There we go, Kaylee. Sorry, Liaho. If you see the question now and you're like, never mind, I don't want to answer, then that's fine also. Okay, but so here's the deal, right? When I was doing this, I told you guys I'm running out of brain breaks. I've prepped our lessons for the next like 3 months. So I still have a few, but yeah. So if at school, this is like just specifically at school. At school, you have no school bag, no lunch. You still get a break, but you don't get lunch. You don't get to eat during school, and you have no stationery. So you can't make notes, you can't like glue worksheets. You can't do anything at school. You just have to listen to the teacher and remember. With textbooks, there's no textbooks ever. There's no textbooks ever. So even when you go home, there's no textbooks. Okay. So the only thing you'll ever have to learn from is your teacher, what they say and what they write on the board, and maybe if they give you worksheets. So that's the scenario. No textbooks ever. And then school bag, stationery, and lunch is just at school. There's none of those things. But when you get home, you have stationery, you can make your notes, blah, 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 blah. That's the question. We have Rory-san first. Yes, Rory-san, I hope you thought about your answer. What do you think?
Ma'am, you said one must go, but I want everything to go. Like books can go, bag can go, station, because those things make my bag look like as if I'm a god. Like it makes my bag look uncomfortable. So, but okay, one must go. I'll choose textbooks and bag. Yeah.
So you're not gonna have a bag, so you're gonna walk around carrying your books and your lunch in your hand.
Yes. 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 I
Rory-san,
do
that's
not.
a bold choice. But okay.
I do not like. I'd rather hold a pencil and a pen. That's all.
Oh my word. No, man.
Yeah.
I personally would get rid of lunch because like I can tough it out, you know? I can tough it out until I get home. But like stationery, I have to make notes. Like I have to have a book. You know, even let's just say we're not even using our books to work. We're just using the books to draw pictures and write notes to our friends. Like we need paper
Uh,
and pencils, you know.
nope. At my school, I stay for 7 hours. So without lunch, that could kill
Yeah.
me. That could kill me.
Okay, Marisa, it's fine. I'll see you walking around with all your stationery in your hands.
Yes, ma'am. Thank you.
Thanks, Marisa. And then, Liaho, I'm so sorry. I'm so sorry, friend. I'm skipping you.
Ma'am,
And
you like
Kate,
doing this.
I'm sorry.
But anyway,
Hi,
ma'am.
ma'am.
Let me just be quick, ma'am. I'll just say stationery. I'll get rid of stationery.
Okay, Liaho, thank you for answering. Yes, Kaylee.
Hi, ma'am.
Hi.
So personally, I wouldn't get rid of lunch because what do you mean I have to get rid of lunch? Nah, I'd say stationery because the textbooks have like the information, so I don't need to make like these aesthetic notes, which I love, but then I think I'll have
That's
to go
also
stationery.
true. Yeah, that's also true. What I do know though, Kaylee, is that I wouldn't get rid of textbooks because some teachers are like, you know, I don't want to like trash talk
Yeah,
teachers, but you know how it goes. Some teachers don't know how to teach in the way that you understand.
yeah, that's like
So
my
then
math
it's like,
teacher. That's why I'm doing extra classes.
You see, so we need these textbooks so we can learn by ourselves when our teacher like wasn't doing it for us, you know?
Yeah.
So yeah, I respect you saying stationery because you'll have your textbook still.
Thank you, ma'am.
Thanks, Kaylee. Okay, guys, that is that for our brain break. I'm gonna lower everybody's hand super quickly. Christian, I'm so sorry. I'm skipping you too, you and Liacho. But that's that. I think that was the last of our brain break. Yep. I want to go back. I want to do, I don't want to do this question because we've done quite a few questions like this, like B. What I do want to ask though is I want to ask you guys how many terms are there in B? I just want to see. Two, one, four. Um, three, four. Okay, remember, let's talk about it. When we say we're looking for a term, terms are separated by a plus sign or a minus sign. The next thing you should know is you must ignore signs that are inside brackets when you do this. So really what happens is the brackets hold all of our terms inside the brackets together. So inside this bracket, there are two terms, okay? They're separated by this minus. But when I look at the expression by itself, this whole thing over here is one term. Why? Remember, I ignore the sign inside my bracket. And so then we have 6 and we have a bracket. Are they separated by plus or minuses? No, they are not. So this whole green thing is then one term. My next term is 3 times x times y. Well, why is that not like 1, 2, 3 different terms? Because these are separated by multiplication. Okay. Separated by multiplication does not create different terms. It has to be separated either by addition or subtraction. So, Christian, I see you're saying that it makes sense now that it's two terms. So I'm glad to hear that. Anya is giving us the answer 6xy minus 2x minus 2y squared minus 3y. Is that the answer, Alia? Because that's basically just what the question is. Yes, minus 3xy is the second term. The answer here would have been, okay, let's do the question. 6xy, and remember we're multiplying the numbers here. So it would be 6 times 2, which would be negative 12y squared minus 3xy. And because we have xy over here and xy, 6xy minus 3xy gives us 3xy minus 12y squared. So that is my actual answer. So Christian, yes, you were right there. But then what you have to do is then still add your like terms. So there you have 6xy and the negative 3xy. Bring those together and you'll end up with 3xy. So that's that on that. Moving on to the next one. I hope nobody has questions on this one because I don't think it was the hardest question in the world. But if you do, ask in the chat. Ask in the chat or raise your hand. Moving on to C, very similar. I'm going to ask the same question. How many terms are in this question? How many terms are in this expression? This is 3. Shady. Hi, Shady. I didn't know you joined us. Ding, ding, ding. Christian is on the money. I know Christian is not the first one that said it, but I just noticed that he did. But yes, it's 2. Remember, I'm ignoring this. I ignore this sign. The sign inside the bracket, I ignore it. Is anything here separated by pluses or minuses? Nope. So it's all one term. Then we have this minus separating something, and no plus or minus being separated there. And so we have our 2 terms. I have to erase all of that. If I were to actually now go ahead and do this question, if we have to go and do this question, Shady, that's okay. It would be 7a squared. I can't simplify 7a squared. Remember order of work. Number 1, identify terms. Yes, Rory-san.
Ma'am, is the answer negative 15a to the power 4?
Well, stay with me and we'll see. And add or subtract like terms. So in case anybody forgot, we first identified our terms. Now what we go and do is we simplify our terms. I've brought 7a squared down because I can't simplify that term anymore. Let's now go and simplify my pink term. It's going to be negative 2 times negative 3a. It's a negative and a negative, which is going to give me a positive. 2 times 3 is going to give me 6. Oh, that's my bad. The square is outside. So I'm going to keep my negative 2 and I'm going to first distribute my square into my bracket. Okay. Distribute my square into my bracket is going to be negative 3a multiplied by negative 3a. That's going to give me a positive 9a squared. Okay. Positive 9, so it's going to be 9a squared in there. I can simplify that more, so let me bring 7a squared down. There's going to be negative 18a squared. So Rory-san, I heard 15 when you asked me. So I'm thinking you didn't get the same answer. Then we have 7 minus 18 is going to give me negative 11a squared. Rory-san, you with me on how we got to this answer?
Yes, ma'am. Yes, ma'am.
You sound a little bit confused. What confused you?
Ma'am, I said 7a squared minus 2. And then that way I didn't see the square outside the bracket there. So yeah, I didn't see the equation fully.
Yes, we have to be very, very careful about that. And then also, remember this 2 is part of its own separate term. So because it's being multiplied here, you can't separate it and then go 7 minus 2.
Yes,
So
ma'am.
be careful about that. But I'm glad that you're with me now and understand how we got here.
Yes, ma'am.
Thanks, Rory-san. Okay, I'm not seeing questions in the chat, so I'm going to move on. Remember, guys, you are always, always welcome to ask me questions or answer with me where you feel you know how. Last question before we close up, we're looking at A. So what am I doing? Can I simplify my numerator or denominator? Yes, I can. I don't have to break up my fraction just yet. On the top in my numerator, I have 3a squared. Remember when we did our exponent rules, we said your square, your exponent goes into each number and variable inside your bracket. And so on the top here, that squared is going to change into 9a squared. Okay? Multiplied by, let's get rid of this cube here outside my brackets. So if I bring that in, someone tell me what is 2 cubed? Yes, Uma, distribution. 8. Oh, wow. I'm surprised you guys got that super fast. I'm happy to hear that, though. 8, and if I bring this 3 into my a, it's just going to be a cubed. At the bottom, oh, can't go a straight line for anything. At the bottom, we just have 6a to the power of 4 multiplied by 12a. Now remember, I can just remove those brackets there because I'm doing multiplication. It's only when we're doing addition or subtraction outside of my brackets that I have to do the distribution in. So remember, different rules for like terms, different rules for exponents. When we're dealing with multiplication, we deal with our exponent rules, and when we deal with division. So for now, I could just remove my brackets. I did see that my 6 looked like a B. I thought the same thing. I don't know if that helped it, but whatever. Then let us multiply. My exponent law tells me when I have the same base, I can keep my same base multiplied to each other. I can keep my base and add my exponent. So I have a to the power of 5 on the top. 9 times 8. Can somebody tell me what is 9 times 8? 72. Thanks, Uma. And at the bottom, again, I have the same base, which is a and a. So what I'm going to do, and remember, really what I did here is I followed S and V. So let's multiply my signs. And remember, S and V, I can only apply when I'm doing multiplication and division. Let's multiply my signs. It's a positive multiplied by a positive. That's going to give me a positive at the bottom over here. Let's multiply my numbers. 6 times 12 is what? 72. 3. Still the same answer. 72. And then my variables is a to the power of 4 multiplied by a to the power of 1 with my exponent laws. I'm gonna keep my base, add my exponent. And can you guys tell me what's my final answer here? Rory-san, yes.
I think the answer is 72 a to the power of 0.
So first things first, it is a to the power of 0 because you said 5 minus 5, right? But remember, this is also 72
Yes.
divided by 72. What's 72 divided by 72?
1.
1. So it's actually 1a to the power of 0. But Rory-san, my next question to you is what is the answer of anything to the power of 0?
1.
1. So really, it's just 1 times 1, which is just what, Rory-san?
1.
1. There you go. Happy?
Yes, ma'am.
Thanks for answering, Rory-san. I don't know what's going on in the chat. Let's please be very, Uma. If your friend gave you passes, please use your passes with your friend. Let us be respectful in the chat. And that brings us to the end of our lesson. I do see I went kind of over time.